So imaginary numbers are any number that you have that is under a square root that is negative is considered to be imaginary. So not all quadratics have real number solutions. So in the last example, if you look above, it was no real solutions. And the reason why is because you had a negative under a square root. When that happens, we call that an imaginary solution. Once we start graphing, you'll see how if you have real solutions, it means that you're able to see where the graph intersects the x-axis. If you have a graph that never touches the x-axis, so maybe your parabola is way up here and it never touches the x-axis, it still has solutions, but they're not real. They're imaginary. So we're going to find out how to solve for imaginary solutions and what they are. So I'm going to write you so the letter I represents an imaginary number. So we represent that as the letter I. And I to the first power is the square root of -1. So now anytime you see the square root of negative anything, I'm going to say that is now calling that I. I squared would be like taking the square root of -1 times the square root of -1. And basic algebra tells me that is what? Just -1. So now I've got I cubed, which if I said I cubed would be I squared times I. I squared is what? -1 times I, so it's just -I. I know you're like, what is happening? And I'm about to...
So just
Not -1 or just
Wait, you
negative
can't...
I.
Negative I. -1 times I is just -I. Then I to the fourth is like saying I squared times I squared. So that's like saying -1 times -1, which is just 1, positive 1. Then I have I to the fifth, so I'm going to take I to the fourth times I, which is just like saying 1 times I, which is just I. Then I to the sixth is like saying I to the fourth times I squared. I to the fourth is 1. I squared is -1. 1 times -1 is just -1. Now, are you starting to see a pattern? Where does it start repeating itself?
T squared. I squared.
It's an
It looks
I.
like a T though.
And whenever we are doing I to the first, I'm calling that I. I'm just telling you what it symbolizes. So the square root of -1 is just I. So it goes I, -1, I, 1. I, -1. What would you predict that I to the seventh would be? -I. And I to the eighth would probably be 1. So how many times is it, or when does it repeat? Every what power? So I to the first and I to the what are the same? I to the fifth. So it cycles through every 4 powers. So every 4 powers, or every 4 exponents, it cycles through. So the pattern is I, -1, I, 1. I, -1, I, 1. And every 4th power is going to be the same. So 1 and 5 are going to be the same. 2 and 6, 3 and 7, 4 and 8. Then it would be the same. 4 and 8 would be the same. 5 and 9, 6 and 10, 7, 11, 8 and 12 are the same. So every fourth power is going to be exactly the same. So if I said, and you'll definitely get a question like this, if I said, what is I to the 87th power? So what I could do is I'm going to divide 87 by 4. And I don't know what that is. So 2. Wait, what am I doing? 2. I know. How do I do long division? 0, 7, 1. So it's remainder 3. So if my remainder is 3, which one is it going to match with? The first, second, or third power? Or fourth power? Third.
Serious?
So then my answer would be negative I.
You're kidding.
I'm not kidding. So whatever your remainder is what it's going to match with. If you have no remainder, if it goes into it evenly, then it's going to match. If you have a remainder, like it's going to be 1 if you have no remainder. So 0 remainder would be I, would match I to the 4th. So it would just be 1. If you have remainder 1, remainder 2, remainder 3, it's going to match whatever exponent the first 4 are. So it's always going to cycle in that pattern.
So if it's 0, it just...
The answer is 1.
Okay.
If it's remainder 1, the answer is I. If it's remainder 2, negative 1. Remainder 3 is negative I. Okay, so let's go to the next type of problems that you'll see. Here we have just negative under the square root. There is nothing fancy about this than changing this to be I square root 24. From here, I will now simplify the stuff under the square root. So what can I take out to simplify square root of 24? What's a perfect square I can take out? 4 and 6. So then it becomes 2I square root 6. Because I changed this to be square root 4 times 6. 4 jumps out in front to become a 2.
Why when you put the I, why did that make it the square root become positive?
So by taking this negative out, it becomes an I. Because if I wrote this the long way, it would be like negative 1 times 24. Well, this square root of negative 1 comes out as an I.
But why is that imaginary? That doesn't... Why is
So
that-
any negative square root is an imaginary number.
Okay, never mind. That makes sense.
So try number 2.
So,
Simplify
like,
it
the number
completely.
that comes out will be in front of the I?
Yeah, the number that comes out, put that in front of the I. So try number 2. So what'd you get? 2I root 10. What about number 3? Five I root 3. And number 4. Can I take any perfect squares out of there? No, so it would just be I root 21.
Okay, it sounds easy.
It's not bad. Okay. Number 5. I have 2 square roots multiplied by each other. I want to simplify each one separately and then combine them. So let's look at square root of negative 36. What does that become? 6I. And what about the square root of negative 16? 4I. So now I have 6i times 4i. The way we multiply anything, we combine like terms. Well, 6 and 4 are like terms. They get multiplied to be 24. Now I and I are like terms. So that becomes I squared. But anytime you have an I squared, we do not want to leave it like that. I squared is -1. So negative 24 is my final answer, because this equals -1. So you can leave an I and a negative I in your answer. So like if I have just I leave it like that. I squared, so I squared, I need to change to -1. I cubed, I can keep as -I. And then I to the 4th, I need to change to what? Might need to go back and look at it. 1. So if you end up getting an I squared or an I to the 4th in your answer, you need to change that to be -1 and 1. I you can keep as I, and then I cubed you can keep as -I. Those are the two instances in which you would keep an I in your answer. Okay, try number 6, because we did one just like that. So my first step is to do what? Divide by 82 by 4. So my remainder is 2. So then I to the 82nd power is going to look exactly like I to the what power? The second power, which is -1. Good. Yeah, it's not that bad. Okay, here we're going to combine like terms. So I'm going to combine my numbers. And then I'm going to combine the i's. So 2 minus -3 would be the same as saying 2 plus 3. Which is what? 5. -5i plus 8i would be what? Yep. And since it's not an I squared or I to the 4th, I can leave it, or I cubed. Try number 8. -5 minus I.
Yeah. Where'd you get 15?
Oh.
I think he did
Oh, yeah,
7
I
plus
did
8.
7 plus 8.
Yeah. So it'd be plus 7 minus 8. So minus I. And 1 minus 6. Okay, number 9, I am distributing. So when I distribute, I get what?
-4i plus 6i.
-4i plus 6i squared. This changes to be -1. So my answer is -4i minus 6. The I goes away. Because this is -1.
And that's it?
Mm-hmm. Okay, try number 10.
Count off of that if we do that.
No. So this gets simplified to 9i. This gets simplified to 10i. So 9i minus 10i is -I. We're going to skip number 11. You do not need, this is a little more complicated, so we're going to skip that.
Will we see that again?
No.
Thank you.
You're welcome. Number 12, multiply all my numbers, then combine the exponents of i's. So would I add the exponents or multiply them? Add. Why?
Because they're
Because it's small.
Is there in parentheses?
That's not the reason why.
by
They're side by side. Side by side. So numbers multiplied together get me what?
Negative.
Good. Exponents added together get me I to the 8th. Just looking at it, I already know that that's going to simplify to 1. Good. So it just essentially goes away because I'm multiplying it by 1. So my answer is just negative 80. Okay, with this, gonna factor. This should be, okay, it already was fixed. So if I were to factor, or I guess FOIL this, just by looking at it, what is it gonna be? Don't even do it the long way, do it the short way.
4i squared.
Would it be plus or minus 4i squared? Minus 4i squared. What is that called? Not a perfect square.
Oh.
The difference of two squares. So what it ended up being, we went the opposite. Remember, like if I were to factor what I have in green, it would become what is circled. So if it's plus and minus, then you square both of them. So I've got 49 minus 4i squared. You can do it the long way, just trying to encourage you to do it the short way. 1 plus 2i. Now I FOIL this again. 49. What's 49 times 2?
98.
Plus 98i. Wait, hold on. I'm going to erase this. There's something that we could have done that we didn't even have to FOIL it out.
Can't you do the I squared and change it
Yes.
to 1 so then the answer would be 53?
I could change that to be a what? A negative 1, which makes this become 49 plus 4, which becomes 53 times 1 plus 2i. Now go ahead and do that. That makes life easier. $53 plus 106i. Yeah, so before we even, if we did FOIL it, it would have worked out the exact same. It just would have been more steps. So anytime you see an I squared, go ahead and change that to negative 1. Or anytime you see I cubed, change it to negative I to the 4th, change it to 1.
Do we have to solve for x today?
Yes, we do. We get to solve for x today. All right, so we're going to do some solving for x. It's not going to be too complicated, but I'm going to show you. In the past, anytime that we have said negative square root, we have said it is no real solutions. Now we are mature and smart enough to know how to fix it.
No.
We have passed the threshold of saying no real solutions because we now know what imaginary solutions are. So let's solve for x. Let's just try to get x by itself. We're not going to try and do anything fancy. Just get x by itself. What would my first step be?
Move the 11 over and then divide by 2.
Move the 11 over and then divide by 2.
Did you say this is an important class?
Mm-hmm.
Of course, David's missing it.
Where is he?
Cross country.
Oh.
So negative 48, when I divide by 2, becomes what?
Oh my god, I'm much negative.
What do I do next? Square root it. So x equals plus or minus the square root of negative 24. Yes, we have already done it. Plus or minus 2i root 6. I want you to try 15. Okay, for this one, plus or minus I square root 6. There's no perfect square I could take out of this one. All right, try number 16. Okay, so for 16, plus or minus I root 10, and then 17, plus or minus 2I root 2. This is just solving by square roots, pretty simple. So I want us to go back, our last thing, go back to the example of the quadratic formula with the no real solutions.
No.
So that would have been, I don't know what number it was. Let me go back.
C.
Yeah, number C. And what did we get to? I think I have the answer pulled up.
Negative 3 plus or minus the
Negative
square root
3.
of negative 16.
Negative 3 plus or minus square root of negative 16 over.
So we had x equals negative 3 plus or minus, what was it, the square root of what?
Negative 16.
Negative 16 over 4? Or over 2, okay. Now, we just stopped there and we said no real solutions.
Yep.
Using our mature abilities, imaginary abilities, let's go ahead and get a final solution for this. So, I can simplify this to be what?
4.
4i. So I'm going to say negative 3 plus or minus 4i over 2. 4 and the 2 can reduce. So my final answer is x equals negative 3 plus or minus 2i. So it doesn't have any real solutions, but it does have 2 imaginary solutions. So what I want you to do for homework is complete the part 2 of imaginary numbers. So what numbers is that? So your homework is going to be 4.3.
1 through 26. Oh, we don't know 22.
1 through 22.
Who sits in a room and comes up with this stuff?
And then I want you to go back to, so this is the part B.
I think you insulted her, Tom.
I want you to go back to the 4.3 part A. And I think there were 6 of them, right? If you got an imaginary solution, or if you said no real solutions, I want you to finish with the imaginary. So Tommy said he got a lot of no real solutions. 2 of them.
Yes.
I want you to fix those. So finish them out with the eyes in it.